The next application questions deal with the percent discount or the percent markup. So before we try to solve these, it's important to understand the basic concept. So the basic concept is this. You will have some sort of original price. That might be a wholesale price, that might be the original price in the store. So you're going to have an original price. You're either going to add or subtract to that the change in price. And they will tell you what the change in price is, but the important thing to remember here is the change in price is going to be the percent times the original, the percent as a decimal times the original. And that's going to give you your new price, which might be a sales price, etc. So your new price. So you're going to have your original price, something's going to happen to it to add or subtract, and then you're going to end up with whatever your new price or your sales price is. So let's take a look. On my first question, I have a college bookstore that uses a standard markup of 40%. So markup, obviously we're going to be dealing with plus right now. So a standard markup of 40% on all books, purchased wholesale from the publisher. The calculus book sells for $179.20. What's the original wholesale cost? So this is the question that I'm answering. So that is what X is going to be equal to, or you can use W or P or whatever variable you choose. But the original wholesale cost is going to be X. So now I'm going to go back up here. The original price, that was X. I'm going to add to that because it's a markup. I'm increasing the price by 40%. So a lot of people are tempted to just put 0.4, but it's not just 0.4 because that would be 40 cents. It's 40% multiplied by whatever the original price is. So that's the percent times original I referred to. So I'm increasing it by 40% of the price. And that is going to be equal to $179.20. Because that was the new price after I increased the price. So now I just have to solve. So on the same side of the wall, I have two values with an x, which makes them like terms. This is a 1x because if there's no number, it's a 1. So 1x plus 0.4x equals 1.4x. So all I'm going to have to do now is divide each side by 1.4. And when I do that, I get x equals 120. So again, this is a story problem. It's good to write a sentence. So the original wholesale cost was $120. And that's it. Go ahead and try that other one and then press play to see how you did. So for our second example here, we have an online bookstore that's giving a discount. So now instead of the plus that I used on my first question, I'm going to subtract from the original price to get a new lower sales price. So again, I'm finding the original price. So that's what I'm going to say is X. X is my original price. So my original price, X, which is where I always want to start, original price. This one we already said we're going to subtract because it's a discount. So minus. And it's 20% of the original price, so 0.2x, not just 0.2, but 0.2x. And that's going to give me my price of $5.28. Same concept as the last one. If there's no number, there's a 1. So 1 minus 0.2 is 0.8x equals 5.28. When I divide by 0.8, I get 6.6. And the question is, what was the original price? So the original price of the book was $6.60. And that's it.